Hi, it's Eamon with ipXchange here at the Indie Semiconductor booth, who have recently acquired Silicon Radar. So recently, in fact, that we've still got all the Silicon Radar signage. Brendan and Wojciech.
Yes.
We're doing a small series of videos on quite a few of the different radar technologies that are on this booth.
Well, basically it's a strategic acquisition for Indie Semiconductor. We're focusing on all the major sensor modalities for autonomous driving. Radar very important, and I think what we will bring to the table, we will enable Silicon Radar to scale their business. Okay. That's in a nutshell.
So, okay, I can see these are the 120 hertz transceivers. So what kind of sets them apart from other radar transceivers?
Yeah, so the biggest advantage is the bandwidth, which those chips offer, and with the higher bandwidth of 20 gigahertz, which we reach with this chip, one can increase the accuracy of the measurement at very high frequency. So the chip has integrated antennas, so the usage of this chip is very easy and straightforward. Nobody requires any RF know-how to use it, and it can be mounted on a very regular FR4 PCB, and or if one wants to use it immediately, it can be plugged into our evaluation kit board and used without any extra effort.
Okay. So what would you say are the kind of, if a design engineer was going to use this, what do you reckon would be the ideal application, kind of the sweet spot that you can imagine these being used in?
So I had quite a lot of different applications. So predictive maintenance is something where those chips are tried to be designed in. That's, let's call it, main industrial application field. There's also vital sign, also pulse detection, because the bandwidth increase the accuracy of measurement, and that's what can be those applications can be reached with this chip.
Okay, so that's the 120 gigahertz ones. I see you also do 300 gigahertz. So where would you find that used?
So 300 gigahertz is a chip which gets to the limit of the technology of silicon germanium technology, which is currently available, and the chip achieves 40 gigahertz of bandwidth, meaning one can do material testing, non-destructive material testing with the chip to analyze, for instance, the thickness, measure very precisely the thickness, or monitor the thickness during the production process, monitor the density of the material, or measure the density of the material which is produced in line. Inline inspection is also another interesting application. So a lot of processes have to be monitored during the fabrication, and those chips find their applications over there as well.
Cool. And does that one have evaluation kit as well?
Yeah, exactly. This chip matches to our strategy. It can be tested on our Easy Radar kit as we provide it as on a plug-in board, and then you can simply plug it in and try it out.
Cool. So now I'm here with Francisco. He's going to show us through some of the applications of Silicon Radar's technology in this industrial monitor application. So what's going on here?
Actually, what we created using Silicon Radar's 120 gigahertz device is vibration monitoring and predictive maintenance of any motor, any machine, any electrical appliance that you need to measure without contactless or from a distance. So we are able to detect distance and the RMS of any machine that is working. So by just seeing its frequency and their vibration, we are able to know if the machine is running good or if there is some drifting in their behavior. So, and we are quite happy of that, because actually we were nominated as one of the best embedded awards solution in the exhibition. Nice. So yeah, it was really nice.
Cool. Can you just give me a little bit of information of what exactly is happening here? Oh, I see that's a speaker now from this side.
Exactly. We have a speaker
that makes
simulating
sense.
a motor. Yeah. So we are able to control it with some phone application, and we are able to change the frequency and to see some behaviors, if it's working right, if it's drifting. So we are able to get information out of the system. Usually we use it with regular motors, but here at the exhibition the space is not so big. So yeah.
So what? And what's the kind of the range that this can do detection at?
Actually, we are working with some motors on real environments for tens of meters. So
okay,
yeah,
so
at airports and,
yeah.
and ports as well. So yeah, we are able to use it on open space, and this is one of the big benefits of this solution, that you are not you don't need to be in close contact with the device you want to measure. So you get a lot of information out of it, even from quite far away.
Cool, excellent. Is there anything else you'd like to add in terms of the demo?
Yeah, I mean, of course, we are able to get a lot of information about vibrations. Sorry, I need to.
Yes, all right.
Yeah. About frequencies, modes of working, so to get other misbehaviors of the system. So you are able to filter and to customize the solution for any specific need that an industrial customer may have. So yeah.
So we're at our next demo that uses silicon radar's technology with Benjamin. So what's going on here? I can see a lot of sponges spinning.
Yes, so what we are doing actually, we are using radar for improving manufacturing lines, production lines. So usually you would think that, or the usual state of the art is that if you want to see if your product is correctly produced, you have to take out a sample and run to the lab, then go back, adjust your parameters and throw out a lot of waste. So what we are doing here, you can see we have 4 samples, and with the radar we are looking onto the samples and determine thickness and density. So you could say we are measuring the weight of these objects without touching them.
Oh, nice. So I guess this would speed up the process a lot, because you're not having to take random samples out. You can do it on the assembly line, and you probably have a much higher accuracy because you can test everything technically.
Exactly. So in the production line, we are with the accuracy, we are basically in the range of micrometers, and that is quite good, and mostly even better than tested in the lab.
Yeah.
And the good thing, or the great advantage, is actually that you have the result right away. So during the production, reaction to maybe wrongly produced products, or even if there is a small defect like an air bubble or something inside, can be detected, and then not the whole product must be thrown away, but maybe just part of it.
No, so it saves material as well, because you're really, the detection is on the production line. So yeah, that's really cool. That's really cool stuff. So I guess this is mainly designed for kind of industrial assembly line. Are there other applications you could see this kind of technology be using?
There are quite some applications we also use it in. So we have been using it in industrial applications, but also in agricultural applications. We are sometimes putting our guys onto a drone, and then looking down onto the field, and also measuring, for example, the thickness, or in that case, the height of the plants.
Oh, nice.
Or detecting also defects, let's say, like foreign bodies, like stones, metal pieces, or even animals.
Oh, that's very interesting. So, very versatile technology. Is there anything else you'd like to say about Silicon Radar?
So we are actually very happy that they invited us to the show, and we are happy that we can present an application with their sensors, and we find it quite successful today on the show.
Oh, excellent. And what do you reckon the next show you'll be at is?
So usually we are visiting the show Sensor and Test, that will be in May, and that'd be the next one for us, actually.
Nice. Okay, well, it's been great to talk to you, Benjamin. Lovely demo, and all the best.
Thank you.
Eamon always sits on chairs in weird ways, so I'm one-upping him today. It was great to revisit Silicon Radar. We did previously interview Anya at Electronica. This offered a bit of a different perspective because we had the 2 demonstrations. If you're inspired by what you see, then head to ipXchange.tech, follow the Silicon Radar news article from the front page, or just follow the link in the description. Thank you for watching.